Hi guys, today let's discuss a house robber 2 question. This is also going to be a dynamic programming question. And if you are coming to this question, house robber 2, then most likely you must have solved the house robber 1. And the only variation from the house robber 1 is going to be the houses in this question are arranged in a circle. So which means the house 0 and the next house to the house n minus 1 is going to be house 0. So you cannot rob both the first house and also the last house given in the array. So that is only going to be the variation. So let's look at the examples. So the first example is 2, 3, 2. So in this case, the answer is going to, we can only rob one house out of these three houses. Because if you are robbing the first house, then you cannot rob the second house as well as the third house. Because the third house and also the first house, they're already connected next to each other. So in this one, you have to pick the max out of these three. So same goes for even the last example. So there are only three houses. So whenever there are three houses, you have to pick the max amount of money in which house it is there. That is going to be the answer. And so let's look at the second example. Here 1, 2, 3, 1. So here in this case, we are going to rob the first house as well as the third house. So that is going to result in 4, and since this 1 and 3 they are not adjacent to each other, and also they are not the first and last house, so these two houses can be robbed. So that a maximum amount of money that can be robbed from these two houses is 4. So the constraints is also going to be the same. Let's go into the explanation part of it. Hi guys, let's consider two examples. So the example 1 is going to be the houses in which 3 houses are present. And in the example 2, we are considering 4 houses. The reason I am considering 3 houses and 4 houses is because 4 houses generalizes for all the cases, and 3 houses will generalize for all the houses less than or equal to 3. So in this example 1, what is the maximum amount of money that can be robbed from all these 3? Sorry. The maximum amount of money that can be robbed from all of these examples, it is going to be the max of nums. The reason being, if any of the house is robbed, other house cannot be robbed. In this example, if you consider we are robbing the house 2, and since the other 2 houses are adjacent to the house 1, we cannot rob any of this house. In this case, if we are robbing this house, the house 2 cannot be robbed because they are adjacent to each other. And the last house also cannot be robbed because they are again connected in a circle. Okay. And in the third case, also we are going to rob the house 3, but the second house cannot be robbed because they are adjacent to each other, and house 1 cannot be robbed because they are again connected in a circle. So for all the houses less than or equal to 3, we are going to return this max of nums. And let's go to the second example. So where the houses is greater than or equal to 3. Greater than 3. So in this scenario, there are 2 cases that exist. So one is case 1, and so case 1 is going to be, we are exclude last house. Exclude our last house, I mean, we are only going to consider 1, 2, and 3. Rob only these 3 houses. Okay. And this is going to be my case 1. And my case 2 is going to be exclude first house. So in this case, I will only rob 2, 3, 1. Then what I am going to do with these results? So I am going to return the max. Then I am going to return the max of case 1, case 2. So this is going to be my result. So the scenario that we are solving is the first house and the last house are connected in a circle. That is the reason we are actually considering these 2 houses, and we are trying to avoid this scenario. So in this case 1, we are excluding the last house. So which means that first house and last house are no more interconnected. We are only considering the first 3 houses. And in the second case, we are considering the last three houses. So we are excluding the first house. So again that the circular arrangement of the houses is solved. So let's quickly code this up. Let's solve for the corner cases first. If length of nums less than or equal to 3, then we are going to return max of nums. Then we are going to consider two dynamic programming arrays to solve the cases, case 1 and case 2. So dp1, it is going to exclude last house. dp2, exclude first house. dp1 comma dp2, we are going to initialize initially with all the zeros. 0 star length of nums minus 1. And let's initialize the first elements of dp1 and dp2. 0 comma dp2 of 0. So which means that if there is only one house, so the maximum amount of money that can be stashed from that house is going to be the amount in that house. So it is going to be nums of 0, and in the second one it is going to be the first house is going to be the first house. And dp1 of 1 comma dp2 of 1, it is going to be max of, when there are two houses, it is going to be max of nums of 0 comma nums of 1. In the second case, it is going to be the houses 2 and 3. So it is going to be nums of 1 comma nums of 2. So let's run through the rest of the houses. For I in range of 2 to, it should be length of nums minus 1, because that is going to be our the results array dp1. So this is going to be of length nums minus 1. So that is the reason we are only running it till nums minus 1. So dp1 of I is equal to max of dp1 of I minus 1 comma, we are robbing the current house, nums of I plus dp1 of I minus 2. And dp2 of I is going to be the max of, it is also going to be the similar, but the only variation is going to be dp2 of I minus 1 comma. So instead of house I, we are going to consider house I plus 1. The reason being that we are already considering the houses, house 2 is already considered. So we are always going for the next house in that for each I value we are considering the house I plus 1. So nums of I plus 1 and dp2 of I minus 2. Return max of dp1 of minus 1, the last one, and dp2 of minus 1. So yeah, let's comment out this one. Let's quickly run the code. Let's submit it as well. Yeah, hope you liked the explanation. Please like and subscribe to my video. Thank you.